I would like to introduce our first presenter today. Dr. Tara Martin is a professor in conservation decision science with the Department of Forest and Conservation Sciences in the Faculty of Forestry at the University of British Columbia. She's a pioneer in the field of conservation decision science, combining predictive ecological models with decision science to inform what actions to take, where to take them, and when to achieve our conservation and natural resource management goals. So with that, I will hand the floor over to Dr. Tara Martin. Thank you.
Wonderful. Thank you very much for that introduction. Let's get Now, are you able to see my presenter screen?
Looks great.
Super. Well, thanks everyone for joining us this midday on a bit of a rainy day on the West Coast. I'm joining you from the unceded lands of the Musqueam at the UBC campus, but I was born on Salt Spring Island in the Gulf Islands, the unceded territories of the Penelakut, Cowichan, and Wasanic nations. I lead the conservation decisions team here at UBC. I'm a professor in conservation science, and what the main kind of focus of our work is around understanding cumulative impacts to ecosystems. And based on what we find, we then transform that knowledge into solutions, into management strategies that we can take to restore and conserve and protect and steward these ecosystems. So growing up in these landscapes, I spent a lot of time, obviously, thinking about these places, observing these places, and for the last 20 years, collecting data on these places. And in my lifetime, I've watched ecosystems transform from meadows like this, where we have a bounty of incredible flora that support a diverse range of birds and pollinators, to landscapes like this. And now this is the image that most of you who are familiar with the Gulf and San Juan Islands in this archipelago, this image would be very familiar to you. Whereas the previous image may not be very familiar to you. So I've watched this transformation over the last 40 plus years, and I've started to try to untangle what is driving this transformation. This is an island in the Salish Sea. This is what a diverse understory of our forest should be looking like. But this is kind of more commonly what we encounter. And on some islands, this is what we encounter. And so what is driving all of those transformations? I want to think about this quote from Daniel Pauly. So over 30 years ago, Daniel Pauly, who's a renowned fisheries scientist here at UBC, he put forward this concept of shifting baselines. And he says, we alter the world, but we forget what it was like beforehand. And each subsequent generation regards a progressively poorer natural world as normal. So this is what's happening in the Gulf Islands. We have this phenomena of shifting baselines. When Daniel first put this forward, he was talking about fisheries, the fact that, 100 years ago, you could go out and catch this bounty of fish, whereas today, when you go out to those same places, it's very hard to even catch a single fish. These things happen slowly over time. And, when my children walk through these ecosystems today, what they observe is what they think is normal. So we all have this idea of what we think is normal, but slowly that normal is shifting. And ecologically, we're accepting as normal less and less. So what has been driving our ecosystems within the Salish Sea to go from these images, on the left to these images on the right? I should note that these images were taken in April this year, and they were taken on the same day. So this is not a seasonal difference. So what's driving the changes? Well, one of the changes has been this disruption of what we call trophic cascades. So trophic cascades are these linkages that link ecosystems together through these food webs. So the loss of predators in these ecosystems, the loss of cougars, the loss of wolves, and to a lesser extent, the loss of bears, have had a profound impact on their prey, in particular, black-tailed deer. We've also lost hunting. So First Nations who lived throughout these ecosystems were hunting. Early settlers were also hunting. But in the last 50 years or so, there's been very little hunting throughout these islands. And so we have this escalation of herbivores, black-tailed deer, which are now eating most things out of house and home. Of course, we've also had enormous land use change throughout this region. The coastal Douglas fir bioclimatic zone is the most threatened bioclimatic zone in the province. And within that, Garry Oak ecosystems are the most threatened ecosystem in Canada. So we have very little of these intact ecosystems left. But what we do have left and what has been protected is continuing to be degraded. And so we ask ourselves why? Why, if we look at the Gulf Island National Park, this area where there is no more, land use change, why are we still losing species in these ecosystems? And a lot of that can be explained when we think about how these ecosystems evolved in the first place. These are ecocultural landscapes. These are landscapes which evolved over millennia with the stewardship of First Nations in these places. And they were using these landscapes and tending to these landscapes in very important and particular ways. There is cultural burning of the landscapes. There is intense plant propagation and weeding. They're tending to these incredible food gardens. And of course, they were hunting. And then we have climate change more recently, which is exerting pressures on and amplifying all of these other threatening processes. So where the risk of fire is being amplified by browsing, by losing this understory, this dense understory, which can act as a fire retardant. The loss of that understory is then drying out the soil horizon. We have increasing fire weather, and that increases overall fire risk. And climate change is also bringing about new risks too, in terms of dieback of red cedar, for example. So black-tailed deer, they're native to this system, but the system is now out of balance. Across many of these islands, the density of deer is 10 to 100 times what it was historically. So my colleagues and I have written a lot of papers on this issue and have had them published in various journals. But I find that pictures are the best way to tell this story. So browsing, first and foremost, leads to this loss of understory biomass, understory structure, and understory species diversity. So on the left, we have islands where there's less than 0.01 deer per hectare. That's 1 deer per 100 hectares, and you can see that in this image, if you can see my cursor, this is that lush, diverse understory. Lots of shrubs and ferns. And then here we have a common shrub, ocean spray, in its natural state, this full-bodied shrub from its apex down to the forest floor. This is where we get densities of sort of 0.1 to 0.5 deer per hectare. We've lost a huge amount of biomass in the understory. And then we start in this shrub ocean spray, we start to get this kind of umbrella structure of the ocean spray. And then finally to this very high level of deer density where we've got a complete loss of understory. And these ocean spray are really the living dead. They're trying to sprout out from the bottom in response to browsing, but all of those new shoots get browsed off. And eventually they will die, and because there is no recruitment, they will not be replaced. So we can show that with data, and we can show that statistically there's a huge difference between islands that have a low level of deer on them and islands that have kind of moderate and high levels of deer. in that key structural phase, kind of 0.5 to 1.5 meter strata. So that in turn causes a cascade and impact into our songbirds. So our songbirds throughout the archipelago rely on our forests and our meadows for nesting and foraging opportunities. And the loss of that understory vegetation impacts a particular cohort of our songbirds more than others. So the species that rely on the canopy, we find are doing fairly well. They're not being hugely impacted, but those species that rely on the shrubs and on the ground layer for foraging and nesting are the species that we're seeing huge declines. And so again, we have data that kind of backs this trend up, where we've got, the highest numbers of these different bird species on these islands that have very low or even no deer on these islands. And as we increase the deer density, the abundance of these bird species decreases. Deer browsing is also leading to the loss of these culturally significant plant species. Throughout the Salish Sea, First Nations relied on many species for medicines and for food. And two such species, we have sea blush and we have camas. The colleagues of mine, Emily Gonzalez and Peter Arcisse, did a beautiful experiment where they tested whether it was competition or herbivory which was driving the decline of these two different species. And they used exclosures to test these ideas. And they found that when within these exclosures, when deer were excluded, the number of sea blush stems increased dramatically, whereas competition with other exotic plants really had little impact on the number of sea blush stems. Likewise, when we looked at the camas, the bulb of the size of the bulb of camas. So this is a species that produces a corm, not unlike a daffodil or a tulip. And when those species when deer were excluded, we found that the mass of the camas bulbs increased quite dramatically. So camas declines under browsing. We have two species of camas. We have common camas, Quamash, Camassia quamash, and we have gray camas, Camassia liclinii. These were incredibly important sources of dietary carbohydrates for the Coast Salish First Nations, and this plant was traded, up and down the coast and inland. And work by Nancy Turner and Beckwith estimates that, in a particular camas garden, there is around 400 bulbs being harvested an hour. It's between 36 and 40 kilograms a day. Say within the Salish Sea, that's around 1 to 2.3 million bulbs for every 1,000 people a year. So this was a huge harvesting operation, and you can just see the size of the bulbs in that image. These are the size of sort of small to medium-sized potatoes. It'd be very hard. You'd be hard pressed to find a camas bulb that large today, and you'd certainly not be able to find an area that you could harvest that many bulbs per hour. So it speaks to the decline in the extent of this species as a result of land conversion and browsing pressure. So I dream of a day when I can, maybe take my grandchildren through a meadow like this and actually harvest a camas. This is a great quote from James Swan in 1857. He was a 19th century ethnographer and naturalist. And he says, "I never have met with a white person who is not fond of baked camas, and I do not know any vegetable except fried bananas so delicious." I mean, what a delight would it be if we could go out and actually harvest this plant and share in that experience. One of my master's students, Kefra Beckett, is looking at the impact of browsing by deer on bumblebees. So bumblebees are a very important generalist pollinator throughout the Salish Sea. And this is just a picture of Kefra and my research assistant, Abby Sherwood. On the left, we have a site where deer are present. This is Tumbo Island, one of the islands in the Gulf Island National Park. And on the right, we have an image where deer are absent. It's, you almost, again, the images tell the story. There's very little resources for pollinators on these islands where deer are present, whereas on islands where deer are absent, there's extraordinary floral resources, and that's what Kefra is finding, is that bumblebees are obviously responding to these floral resources, and there are much higher numbers on these islands where deer are absent. I want to switch to now so we have a very good understanding now of what the drivers are of these changes, and I wanted to shift to a story about ecocultural restoration. As I said, these are ecocultural landscapes. These meadow landscapes and Douglas fir landscapes were tended by First Nations for millennia, and a lot of the stewardship practices that they used are the practices that we need to think about reinstating if we want to bring back these ecosystems and restore these ecosystems. So 3 years ago, this island called Halibut Island, or Sisqueenum in Senchothan, came up for sale. And this is an island that I had the pleasure of boating past many times as a child. And later, when I was doing research during my postdoc, I had met the landholder at the time of that island, and came to realize that this island was very important ecologically. The owner of the island, Hilton Burry, he passed away several years ago, and the island was then put up for sale by the estate, and I contacted the real estate agents, and asked if I could do a full floristic and fauna survey on the island. And fortunately, he allowed me access. And what I found was absolutely extraordinary. This island was knee deep in wildflowers. It was just an incredible example of a baseline, of a historical baseline of what these ecosystems used to look like. And so from that moment, I decided that I needed to find a way for that island to be protected and to be put back into the hands of the Wasanic nations. And so I was fortunate in that I was able to find a donor that actually transferred the funds to the Land Conservancy. The island was purchased, and now we are working with the Land Conservancy and the Wasanic Nations to draw up a covenant to protect that island in perpetuity. And the wonderful thing about that covenant is we're drawing on Senchothan laws, Wasanich laws, to draw up that actual covenant. And so this was a really historic day when we got to invite the Wasanic leadership to this island, and it was the first time that they had set foot on this island on a very, very long time. When you enter this island, you're immediately struck by the incredible flora and the extent of camas, these incredible camas gardens, things like kakmeen, this lomatium, which is a very important medicinal plant, fields of fawn lilies, this plant called naked broomrape, which has a terrible name but is delightful. Huge chocolate lilies with stems as thick as my thumb. and just a magnificent place that helps us understand what these places used to look like before we changed them so heavily. So what have we learned in our work over the last couple of decades? Well, first and foremost, the loss of First Nation stewardship, including the loss of top predators, is contributing to this phenomena of shifting baselines of what we perceive as normal. Overbrowsing by deer has led to the loss of the wildflowers and has led to huge changes in the structure of the forest and in the composition of the forest, as well as the successional pathways of our forest. It's altering songbirds and bumblebee communities. We know that historic deer densities are likely to have been around 1 deer for every 100 hectare, and we know that from trying to reconstruct, the amount of camas and other food plants that were harvested and the conditions that must have been the deer densities that would have allowed those harvests to occur. Today, on many of the islands, deer densities are often greater than 1 deer per hectare. So we have a long way to go to bring back balance. Ecoculture restoration, this is possible. This image on the right is from an island in the San Juans where we brought back fire, and we've been propagating and reinstating a lot of those practices that First Nations had developed over millennia. So that included the fire on islands where we can't put back fire. We can think about girdling of the firs that are encroaching on these meadows. There's lots of seed propagation. And of course, then there's also management of other invasive species, broom, hawthorn, exotic grasses, and then we have this deer with wings, which are Canada geese, another species that maybe many of you may not realize, but were actually introduced into the Salish Sea in the Lower Mainland in the 1950s, and have expanded and love to browse these meadows. So I'm going to leave it there. Thank you very much.